Hello everyone, my name is Alvin from Uni of Glasgow, Singapore Institute of Technology, Computing Science. Today I would like to introduce to you my final year project, Automatically Extract Ontology Information from User Feedbacks through Natural Language Processing. With more and more companies resorting to user feedback systems to retain their customer, the amount of user feedbacks and variety increases. As a result, I would like to introduce to you a hierarchical approach towards topic modeling that provides two levels of analysis. First level on main topics and second level on subtopics. With that, we would be able to summarize large collection of feedbacks, organize informations, discover specific issues and concerns which allow companies to make swift mitigation. What is topic modeling? Topic modeling is a method under data mining that helps to extract topics that contains valuable insights. And in this project, datasets were provided by Jurong Town Council JTC for both training and official purposes. So here are a list of main stages we took before arriving at LDA results. Stages includes data processing, data inspection, documented metrics, topic model detection, git sampler. Under data processing, we make sure that data are in the correct format in the correct version before moving on to touch on text preprocessing, where all unwanted punctuations, stop words, white spaces, and noises are being removed. On which, we conducted inspection to make sure that the data are properly cleaned before proceeding further. Clean data were then converted into a document term matrix table, whereby the table columns represents the terms and the row represents the documents. Latent Distributed Allocation LDA. LDA view document as a mixture of topics. As such, it deals with a probability of keywords and its occurring patterns to recognize them as a topic. In the end, topic with the highest probability will be assigned to the document. Git sampler, also known as Marvoid chain multi-colloid MCMC algorithm. How it works is that there's a set of feedbacks. A random feedback is selected and resampled based on the other feedbacks. This will then generate a new set of samples, and the cycle goes on until the entire sampling process completes. With that, LDA will know how to navigate during the analysis process. Right now, let's move on to the InfoVis, constructed using LDA Vis, a library in RStudio, and also D3.js. In this InfoVis, there's two different displays. On the left side, it displays all the topics being identified by LDA. And the distance between the circles indicate the dissimilarities, meaning clusters that are similar, topics that are similar are clustered together. Whereas on the right side of the InfoVis, it shows you a list of keywords sorted in descending order. The red bar indicates the occurrence of the keyword in the selected topic, whereby the blue bar indicates its occurrence throughout the entire dataset. If you set the relevancy metric to 0.6, the order will be different. This time round, those with high occurrence in the selected topic and high occurrence in the dataset will be at the top, whereas those with low occurrence in the selected topic and high occurrence in the dataset will be at the bottom. And if you drag the controller further down to 0, this time around, keywords that only appear in the topic will be at the top, whereas those with high occurrence throughout the dataset but low occurrence in the selected topic will be at the bottom. One additional feature of this InfoVis is that when you mouse over to any of the keywords, you would be able to see the topics that contain that keyword. This will allow easy reference and simple analysis during the analytical work. And for subtopic detection, we simply repeat all the stages and phases introduced during the main topic detection. The only difference is the K value that was specified during the implementation. And for our evaluations, we look into two different factors, accuracy and effectiveness. For accuracy, we conducted two different tests, both achieving a high accuracy rate of 85.2% and 83.5%. Achieving high accuracy and high precision with a variability of 1.7. Whereas for effectiveness, we would like to introduce a new technique, hierarchical clustering, which rely on Euclidean distance calculations to account for the dissimilarities between two samples. And based on the calculated dissimilarities, it will be plotted onto the dendrogram. After performing hierarchical clustering, we have two sets of subtopics, one by hierarchical clustering and another one by LDA. As you can see, LDA produced a lesser set of subtopics. As a result, we went on to do an investigation and realized that some of the entries in the subtopic identified by LDA is actually labeled as a topic by itself in Euclidean. This also means that Euclidean did a better job in the second stage by identifying the specific and detailed subtopics. In conclusion, we would like to propose LDA on main topics and Euclidean on subtopics. Reason being, LDA did a good job in identifying generic topics and giving the dataset a general structure at the initial phase. However, when it comes to the second level of analysis, being specific and detailed is the key. In this stage, Euclidean, which is also the hierarchical clustering, did a better job than LDA.